Parabolic functions come in the form of f of x equals ax squared plus bx plus c, where a is not equal to 0. If a is not equal to 0, then our parabola is going to be a curved shape. It's going to have an axis of symmetry. Let's take a look at the previous problem to see where the axis of symmetry would be. If we look at our profit function, it has the formula f of x equals negative 0.01 x squared plus 37x minus 8,000. Clearly the a here is not 0, it's negative 0.01, and our profit function is curved. Somewhere on that curve, there's going to be a maximum, which is the highest point that the profit reaches. In math, it's called a local or relative maximum. Now, if we draw a vertical line which intersects that point, what we're drawing here is called the axis of symmetry. It's a line around which the curve is symmetrical so that the distance from the line to the curve on the left side always matches the distance from the line to the curve on the right side. Now we want to find out where that location is of that vertex. What x value does it happen? Because if the company can figure out the ideal number of items to produce, then they can get the highest profit that's possible if they do that. So let's look at the formula for axis of symmetry. The formula is x equals negative b over 2a, where a and b are constants that come from the formula of the quadratic itself. Now, in our profit function here, a is negative 0.01. B is 37, and C is negative 8,000. So let's go ahead and put in some parentheses in the place of B and A. What we want to do is we want to plug in the 37 into the formula and the negative 0.01. Then we'll divide that to find the location of the axis of symmetry. It's 1850. So what is the interpretation of that? The company needs to build 1850 units in order to achieve the maximum profit. So the company should produce 1850 units to achieve the max profit. Okay, so if we go back to that original problem, we can mark this x value as an 1850. That's what we're finding, the location on the x-axis where that vertex occurs. Okay. One other thing we may wish to find here is how much profit will the company make if they do produce 1850 units. So in other words, we're going to be looking for the height of the vertex. And that's what the next question is all about. Can we find the y-coordinate, or the vertical coordinate of the maximum here? So, we already know the x location of it, but what we don't know is the vertical coordinate, the profit. How much will it be? So we need to let x equal 1850. So go ahead and put that in here. And now we just need to find out what p of x is. But what x do we use? We use 1850 as the input. Okay, so p of 1850 will be negative 0.01 times 1850 squared plus 37 times 1850 minus 8,000. Let's see what that max profit is, and then we can see if our answer makes sense according to the graph. I get $26,225. Okay, so the y-coordinate is 26,225. The x-coordinate is 1850. We can put them together to find the vertex. The vertex is 1850, comma, 26,225. All right, let's find that point on the graph. This is the point right here. Does it look like it could have a vertical intercept here? A vertical value of 26,225. I think it looks good. Great.